Hi, everyone. Thanks for the introduction. So Russell MacPherson from the PEM Technology Gateway up in Sligo. And yeah, a little bit about me before I start. You got a little bit there, but if I give a bit of my background, it's more so you understand the type of question right? But then I'll go and find the answer. So I started as an apprentice in a paper mill, large paper making company, in instrumentation, not pianos and clarinets, but electrical instrumentation. Then went and did a degree in electrical and electronic engineering, then a PhD in applied AI in the electromagnetic space. Then went to work for the UK government in R&D, then joined a big pharmaceutical company called GSK. Did have a presence in Sligo, which is what took me to Sligo initially. Still got a large presence down in the south of the country. And then about 3 years ago, joined ATU when we closed our factory in Sligo. So I took a bit of a career change. So that's me in a nutshell, right? We'll get going with this. I don't mind if people stop and ask questions as we're going. That's no problem at all. If I can't answer anything, I'll try and take a note of it and then get back to you. Before I start, everybody here is a client in the building, yeah? Just so I kind of understand the audience, yeah. Great. Okay, so technology gateways, you may know about them. There's actually one based in the building, part of one based in the building, the Met Gateway. So there's 17 of us based around the country. And they were all traditionally attached to an institute of technology. Now, with the move to technological universities, that's where you find them. Each gateway has its own type of specialism. So, for example, the one here is in the medical space. The one up in Sligo is precision engineering and manufacturing. Sligo has a history of what we call tool making. So you imagine making injection molding tooling, right? That would be the traditional type of thing, or molds for pressing panels for automotive manufacture, right? It's kind of moved on from that. And Sligo still is the national training sort of center for tool making. So just so you know the background of the Sligo Gateway. So yeah, we exist really to be that gateway between industry, and industry can be one person, yeah, up to a multinational. But that gateway of industry into the expertise that exists within the academic institute where the gateway is based, yeah. And with the move to ATU, 3 gateways came together, so it sort of opened up that whole space. There's also WISE-R up in Letterkenny, who I think have given a talk here before. So I won't dwell on that too much. There's loads of us around, yeah. And usually, if you can't get the answer to something from one gateway, we help you find the answer in the network. Yeah. So we always say to people, start with your local gateway. Don't think, oh well, maybe I should be talking to the guys on Waterford or over in Dublin. Yeah, start with your local gateway, and then they can help you find the right one, if the local one that can't help you. The PEM Gateway is also part of a cluster, which is the EMD cluster, which is engineering, materials, and design. And yeah, I'm really not going to. You've read it before I even tell you what it's about, but it's that's what we do in the cluster. So we specialize in engineering, materials, and design. Okay, and then it's really about helping people get access to funding if it's required. Yeah, and thinking of the cluster and the gateway to some extent as your sort of R&D type facility if you don't have access to your own one. And that's one of the ways we like to describe the gateways. You can think of it as your, your sort of virtual R&D partner. Yeah, I'm not entirely sure the slides are quite as they're meant to be coming out, but this is, so I'm not sure if people are seeing this thing in the top right corner about restore pay, if all that's being shared. So
F11.
11. Yeah.
That better?
There we
Yeah,
go. Yeah,
perfect.
yeah. I thought something was yeah. So this is a range of services that PEM offers, right? So the PEM Gateway at the moment is 4 people, right? So don't think 4 people do all of this, right? So it's that gateway to all the expertise that exists within ATU Sligo, ATU Galway Mayo, and ATU Donegal now, right? But predominantly Sligo. So all those things, we're able to provide some level of service. Yeah, not all to the same level, some more, some less. But that's essentially what we do. Yeah, we do more, but then where do you stop? Yeah, this is basically it all on a page. I don't know if these get shared with people afterwards, but it's certainly on the PEM Centre. So it's and when I go through the case, I've got some case studies later, and the case studies sort of touch on these things anyway, and then you'll be able to see if there's anything of particular interest. So I'm going to talk about some funding, right? And so apologies if you know all of this, right? But there'll be some people that don't. So we have one of the most popular things that people use are the innovation vouchers, right? So 3 innovation vouchers, €5,000 each, with a 4th innovation voucher that's co-funded up to 10,000, which means if you and when we're talking to people about innovation vouchers, we like to really position it as a group, as one big pot of cash, right? So don't think of it as individual vouchers. You think of it as, okay, let's for sake of argument, 20,000. You say, okay, I've got 20,000. I'll map out what I'm going to do with the 20,000. Yeah, it just gives a better, you can develop a better picture of where you're going to go with the money. And the innovation vouchers are a great lead into other funding that's available, because they start to paint a picture for Enterprise Ireland. If you go to Enterprise Ireland and go straight for the 200,000 pot of cash, and you haven't done any of the lower value sort of offerings, they may think, well, have you really mitigated some of the risk? Do you really have skin in the game? Has it really got legs? So it's good to do these vouchers, because it helps you build up that bit of a story, so that when you do go for more money, it makes it a little bit more difficult for Enterprise Ireland to say no. Yeah, not that they say no that often, but they can sometimes tweak the funding levels. Yeah, so you need to be a limited company to access these. Yeah, so we get many people coming through the door who are not limited companies. Maybe just somebody who's got an idea, they want to get started, might be a current student of the university. We get a lot of farm owners or herd owners would come in, lots of agricultural ideas. And so we move them towards becoming a limited company. So we work very closely with the local enterprise office in making that happen. It's very easy for them to do. And then one of the first tests of sort of skin in the game is the VAT needs to be paid on an innovation voucher. Yeah. So if someone's not prepared to pay the VAT on the voucher, then you can almost start to think, well, okay. Yeah. And then the €5,000, that doesn't actually go anywhere near the individual's pocket. It never goes into their bank account. Yeah, it's a voucher that they spend with a knowledge provider. And once you have the voucher, you can actually spend it with any knowledge provider. You're not tied to ATU Sligo or PEM. You can go to anyone. Yeah, so you may sit here in Galway. You may get the innovation voucher here, and then you decide, actually, I don't want to, Galway's not the best partner. I actually need to work with the crowd down in Waterford. It's perfectly okay. Great. Okay, I'll go to the next one.
Like Medtronic and use the innovation voucher within?
They're probably too big. Yeah, there's limitations on the size of the company, and Medtronic probably classed as an IDA client, not an Enterprise Ireland client. Now, IDA do have equivalent. Yeah, so for example, we're working with a large IDA client at the moment, and we're using IDA innovation vouchers.
I think the question is, so the knowledge providers are usually third levels or like psychologically.
Sorry.
Yeah.
Right. Yes. My apologies. Yeah, the knowledge provider is a third level institute. Yeah, sorry about that. Yeah. No, you can't take it and go to Boston Scientific and say, can you do $5,000 of work for me? No, sorry. Yeah.
What is it?
So, then one of the other options as well is what's called the IPP feasibility grant, right? So people may be familiar with the IPP program, so it's an innovation partnership program. I'm going to talk about that later as well, right? But there's one of the initial steps of it is what's called a feasibility grant. These are actually really very good, all right? And although innovation vouchers are great, yeah, this is just like a bit like an innovation voucher, but it's 9,000 euros now, okay? And you notice I don't mention VAT, right? That's actually something I must double check. And this allows you to, again, you don't see the money, right? You don't see the money, but it's 9,000 euros that you can get to carry on your work. Cover some of these things, right? You may have an idea and you may be getting a research assistant who's doing some work with a researcher you want to work with, and they can use that money to pay their research assistant to do your work. Yeah. So, when I was in GSK, we used this to develop some work before we went on to a bigger project. So it's pretty good. And if you're keeping count, right, it's 20,000. Now it's 29,000, right? And all you've had to do is pay the VAT on the innovation vouchers, and you're going to claim that back, right? So that's 29,000 already, okay? You generally go one after the other, right? That's how it's done. No, you can go straight from one into the other, and we generally have them ready to go so that so let's take your first innovation voucher. That's done. Then we'll have the second one ready. Once the first one has been reimbursed by Enterprise Ireland, so once Enterprise Ireland pays the knowledge provider, we fire the next one in. And then, now they can take, maybe 3 to 6 weeks to be approved, right? But they're reasonably easy to get, right? On the innovation vouchers, I'm not going to say it's a guaranteed, right? But as long as you don't mention, as long as you're not trying to cover items that are not supported by the innovation voucher, which is basically market research, consultancy type services, right? Then they're very generous in giving them. Yeah. So I think it's very good. So normally the innovation voucher, right? But there's nothing stopping you doing the feasibility grant first, right? Yeah. But from a building up a story perspective, I would recommend the innovation vouchers because they're quick, they're easy, relatively easy to get, and they give you a quick readout on what you're trying to do. Yeah. If you go straight for an £85,000, €85,000 application, it's going to take you 12 weeks to get the money, right? Someone's going to have to pull all that together. It's going to take you, so 6 weeks to pull it together, 12 weeks to get the money, right? You're way down the road, and then you might find out that it's not actually all that it's turned out to be. Yeah. So get going early with the innovation vouchers and then look at what's down the road. The feasibility study as well. I mentioned the local enterprise office. A lot of people forget the local enterprise office, right? They're very, very good. They're very good. Now, they're obviously more on the business side of things. We're definitely more on the technical side of things, but they also give feasibility grants. They will cover market research, getting a consultant to maybe stress test your business case, that kind of thing. They will go up to 15,000, but they only cover 60% of what you're asking for, right? Up to 15,000. Yeah, so you've got to put 40% in. Yeah. And if there is technical sort of development required, that won't be by the local enterprise office. They'll be putting you in contact with somebody like us. We do a lot of work with in our region, the sort of, I'm going to say the more rural region. We get a lot of referrals from the local enterprise office, which is great. Then we have the Exploring Innovation Fund. 35,000, 50% funding. So you've got to find a good chunk of cash to get that going. It's the same sort of thing, okay? But we're progressing up the sort of the value of the projects, right? You can well, you can read all that, yeah. But it's really just showing what's available. And then we go past onto the Innovation Partnership Express. This is relatively new, and this is up to 85,000. I think that's fully funded, right? I think that's fully funded. Caveat that with I'm not 100% sure, right? But you have to be an Enterprise Ireland client, an UDERIS client, so Gale Tax type client, or a client of the local enterprise office to get that, right? Now they are, they've been brought in as a stepping stone to the full innovation partnership, which is like a big application, can take a bit of time to get. This was like an intermediate step, yeah. And then we'll move on to the innovation partnership, which is kind of the big one, yeah. Well, once before you get into the disruptive technology fund and everything. So this is up to 200,000, maximum 80% grant funded, depending on the type of project, right? Now, what I mean by that is if you're going for a pure R&D type project, Enterprise Ireland may only give you 60% of what you're asking for, right? But if you're a bit more mature, R&D type stuff, and you're now really starting to maybe move it into something that's going to go out into the marketplace, and it becomes more of an industrial type project, then it nudges up to the 80. So if you've done your innovation vouchers, you've done your feasibilities, and maybe you've done one of the in-between funds as well, all that's there to support something like this. Yeah. And an innovation partnership is usually then for, you may be employing, so you'll be in partnership with an academic in an institute, right? So you may come to us and say, right, Russell, we've done all our innovation vouchers, we've done our feasibility, this has got legs, we're in it for the long haul. Now let's go for the big pot cash. We work with an academic, right? Academic will then help pull together the case with you, the application. That application goes in, let's say you get the money, then the academic would usually would bring on, say, a PhD student that would then work on the project, with some of their time as well. So the money buys out a bit of the academic time, pays the salary of a PhD student, and then there's some money for not capital equipment. There's other grants for capital equipment, but for some equipment, yeah. And I mean, we finished one of these recently with a medical, in the medical space, and that was 80% funded. So what the company has to put in, and again, depending on if it's a 60 or 80%, the company either has to put in the balance in cash, right? So it's 80%, I think you have to put the balance in cash, right? But if it's at the 60% level, you can put the balance in a mix of cash, sort of your time valued, you can put in materials and time essentially. So I could say, right, well, I owe 40% of the project, but I'm going to make the 40% up by providing materials and time and access to a facility. Yeah. So the 40% doesn't necessarily have to be all cash. Yeah. Then Intertrade Ireland. Now, Turlet mentioned with us being on the border region, right? We do a lot of work cross border. Okay. There's quite a lot of funding out there if you've got any type of cross border initiative or contacts. Intertrade Ireland, like Enterprise Ireland, but for the north, very proactive in supporting local and doing cross-border work. And they have a new program called Business Explorer, early stage access to academic expertise, right? But for this is the way we work it is a business in the north, right? An academic in the south. I'm sorry to use the north-south, but it's just easier to, right? So you have the business up in the north, academic in the south. It can also go the other way, right? I believe they will also do a business in the south and an academic in the north, right? So so if you've got, we quite often will work with a company that's got maybe an office in Belfast, and that's enough. Yeah. So so that's and again, all these things, if it's something you're interested in, I mean, you Google it, you read it yourself, or you talk to us. Yeah, it's that simple. Now I've missed one out. Did I skip past something called Innovation Boost? Did I?
Yep.
Right, I'll go back. So where did I do that? Did I skip past Innovation Boost? All right, okay. Right. So Intertrade Ireland also do something called Innovation Boost. And it's a really good program, right? And we do a lot of these actually. And they, again, I'm going to make it sound like them and us, north-south, right? But it's an academic in the south, a company in the north, or a company in the south and an academic in the north, right? And you get, again, you put an application together, you need, so let's say you would find an academic up in the north to work with. You put an application together into Intertrade Ireland on the Innovation Boost program, and you may be wanting to develop a product, a process, a service, right? And you then apply to them, and they will give you money to put towards the salary of a project manager to deliver the project that you're interested in delivering, right? Okay. So now if you're a one-person operation, that might not be the space you're in. But if you are maybe, maybe 5, 10, 15 people, then you might be in that space, right? You may want to be looking at a new manufacturing process for a device you're developing. You may be wanting to do a bit of, so you may want to digitalize something you've already got, okay? You pull together the application, they will then give you money to employ someone, right? Now, they don't necessarily give you all the money, because again, they're looking for a bit of skin in the game, right? But that lasts for about 18 months. Right, and then they also pay the academic partner. Yeah, but the key thing about the Innovation Boost and really the Business Explorer program is getting access to expertise you wouldn't normally have access to on the open market. Right, that's really what it's about. Okay, I'll go into some case studies. I've probably been talking. Am I okay for time? I'm okay for time, right? So the case studies now. So I'm standing in Galway, right? Surrounded by medtech companies, high tech, in the body, right? I'm going to be showing you things from farming and fishing and manufacturing, right? Okay. But don't think that there's no application, right? So it's what was done in the projects that's the important bit, right? Okay. So here's one from farming, right? Okay. So company called Quarter Crate, and they came to us. So very successful startup, entrepreneurial guys, Limerick, I think. And what we see a lot is they developed something basically in their yard, right? Started off in their yard, farmyard, turned out to be quite successful, right? But the design didn't evolve. So whatever they had in the yard is what they built it with. And that's what got carried through, right? But as they became more successful, then they started to realize it was too heavy, wasn't easy to make. Yeah. They wouldn't have done it if they could start again, they wouldn't do it the same way, right? So they came to us, and what we were able to do is using sort of precision engineering philosophy, yeah, which is really about tolerance and repeatability, accuracy, precision, that type of thing, right? Taking that philosophy, apply it to the design, net thing being reduced a key component of it, the sort of on-off ramp by 23% on the weight, and made it much easier to manufacture, right? Which was key for them. Overall, 30% down on their manufacturing costs. They're delighted with that, right? That was a couple of innovation vouchers and then a little bit of cash from them. Transformed their product. So it's that thinking, yeah. And what we see a lot with the initial designs is on material use, yeah. So very often people have not enough material where they need it and too much material where they don't need it, yeah. So that's something that we can look at. This was if you go to the garage, they use an air gun to take the wheels off your car, right? When you're in the aerospace industry, it's all they only really use air tools, very high specification. Irish company, ATU tools, developing a new one, high-speed motor inside. And again, so it was look at the design, do a bit of literature studies, CAD it up, do some CFD, so fluid dynamics, before they started to manufacture it. Yeah. Then I think this was some rest for them to do some testing. Again, that was a couple of innovation vouchers, and they went on and took that to a new design. So it's not about the air tool, it's about the steps that we're going through. Yeah.
The intellectual property around that, they come across something and really look around.
Yeah.
That's
always with the company. Yeah. Yeah. So it's certainly in the innovation voucher space, right? When you get to the innovation partnership space, there's more discussion around the IP. Yeah. But it is a discussion, and Enterprise Ireland aren't in the business of not funding because they want the IP, right? So, but the academic partner, they may have more of an interest in the IP than Enterprise Ireland will. So there can sometimes be a bit of a discussion, right? But I've never come across one where the IP was not resolved or taken care of to the company's satisfaction. I've never come across that. Yeah. That doesn't mean it may not have happened, but I've never come across it. So another one, oysters, Coney Island. This is up in Sligo. This was actually between, so the company came to us, then it was between some students and our group. Again, the design of it, yeah, so not too heavy, material in the right place, do some simulation. So again, few innovation vouchers, and the company got that prototype. Now, we didn't build the prototype, they built the prototype, but they get the CAD. Yeah. Company up in Killybegs, that if you've ever gone across a gangway onto a ship, yeah, that's what they do. That's one of the things they do. We've got some innovative designs, and again, we did sort of design, look at their design, finite element analysis, stress analysis, too much material there, not the right material there, too many welds, sorry, too many bolted components, too many welds. So just the whole sort of manufacturing thing, yeah. And again, reducing the weight of it. I think we said, yeah, reduce the overall weight. Yeah. This was an innovation boost project between Spectrum up in the north and us. Make these rollers that drive conveyors, having a problem with the rubber. Yeah, and the rubber was wearing away basically on these rollers unevenly. So what they were able to do, so yeah, this is what was happening. So there's quite a lot of polymer expertise up in Sligo. There's a load of polymer expertise, obviously, down this part of the world as well, but quite a bit up in Sligo. And so the academic on the program with the company, they looked at the vulcanization process that they were buying the rubber in for, and also developed this test rig. So that was all CAD'd up, and then they went and built that, and also put some new quality control procedures into the company as well. So that was very successful, actually. They were very pleased with that. So that was an 18-month project. ATU, I think, gets like 35,000 out of it. The company gets money to employ the project manager that does this, and then the company obviously pays for it. We're going to build the prototype, that kind of thing. Then just, I think there's probably come to the last couple of case studies. So this is on marine coatings. So there's a few people actually in ATU up in Sligo who work a lot in this space. So to stop the fouling on ships, but using sort of bio-inspired materials, right? Instead of the way it's currently done is toxic chemicals, right? So when something latches on, it says, well, I don't like that, and it doesn't latch on. And then on the other one, this is on in the septic tank area. I've done quite a few projects in the septic tank area, believe it or not, but it's all about the quality of water going back into the environment. Yeah, so around water testing, removing chemicals from water. But that was designing a new unit for that company. Again, I think that's a northern company. That was another innovation boost. So right, rolling into the end, right? So there's quite a few slides here because I've got quite a few bits of equipment to go through. So I'll go through it reasonably quick, right? Give you a flavour of the sort of thing that we've got access to. So all the equipment I'm about to show you is in our gateway in Sligo, right? So it's not that we have to go somewhere else to get it. It's all in our gateway. So I know you all recognize this as a 5-axis CNC milling machine, right? That's what it is. So 5-axis CNC milling machine, which basically means, so if everyone remembers what a milling machine is, maybe, and the XYZ is your traditional 3 axes. I can cut metal, plastic, I can cut anything really in that machine. 3 dimensions plus another 2, right? I would say that, you know, with tongue in cheek, right? But it basically allows me to move around the workpiece, right? So basically I've got a wrist and an elbow. Yeah. So instead of it just being flat and up and down, I can rotate around it and get in at angles I wouldn't normally be able to. Yeah. So that machine will cut anything. Yeah. So if you're in the plastics business, it'll cut plastic. If you do prototypes from foam, it'll cut foam. If you do prototypes in timber, it'll cut timber. If you do prototypes in titanium, it'll cut titanium, right? And it's got a full 3D, what we call CAM software, So the days of somebody standing at one of these machines and programming it, that doesn't happen anymore. What happens is you take your CAD drawing goes to, let's say, SolidWorks is fairly common. That goes into the CAM software. That calculates the best tool path, right, to remove the material that you need removed. Yeah. Basically turns it into machine code, exactly the same code that goes to your 3D printer. If you do any 3D printing, it's exactly the same. Fires it into the machine, you press start, and it just like your 3D printer, it goes around and it removes the material, whereas your 3D printer is obviously adding material. This is the complement to it, right? Which is, so that was a vertical machine. This is a horizontal machine. So this is a CNC lathe. In retrospect, I should have had the door open on each machine, right? Because what's interesting on this one is on the inside, it has, it's got your main spindle for mounting a piece where you do the machining, but I can then pass the component over to another spindle. So I can work on the end that was being held. Yeah. And perpendicular, it's got what we've called what's called driven tooling. So we can actually mill and drill holes 90 degrees. Yeah. So what it means is you don't have to take the component out of the machine to go and do those operations. And anytime you don't have to take it out, it means you're not impacting any of the sort of the tolerances of your part. This is a 3-axis milling machine, right? Workhorse, and XYZ, right? Very often that's all that's needed for things. So that's available as well. That one you do have to kind of, well, no, we do send code to that. It's a little less sophisticated than the new machine. Then we have, like everybody, we've got some 3D printers, small resin machine, standard sort of PLA type thing, filament printer. This is a large volume printer, 1 meter by 1 meter by 1 meter. For larger components, obviously they take quite a long time to print, but it's available. And then this is actually new. I don't know a lot about it, but the people who have it in the building are very, very excited about it. We know this is the only one in the country because the company this is the first one they've supplied to Ireland. And it will print 8 materials into one job. So it's actually got 8 pods on the side with different materials. And the reason that we've got this is for doing things like PEEK, PEC, so high temperature materials, high performance materials. So we can 3D print PEEK. And it can actually, yeah. And then for certain materials, you can print them all into one job. Multi-print head, heated chamber, heated bed. So the guys are pretty pleased to have that. So, and of course, for those in the sort of medical device space, PEEK would be a fairly common material. Then we have a lab separate to our workshop. This is a low force tensile tester. So it's up to 1,000 newtons. Think of pushing and pulling, right? What we've used that for in the past is for stents. So drug-loaded stents. So you take the stent in its natural form, you then do something to it, you then bring it back and you make sure its mechanical properties haven't changed. Yeah, it's quite important. So we've done that before. We've also tested sheep wool, right? So we do all sorts of things. It'll also, you can do all, then it'll do what we call 3-point bend tests. So let's say you're doing, again, on, let's say, a stent, not just sort of pulling and pushing it, you may also want to test its strength by bending it, okay? Then there's all sorts of fancy things you can do by putting on other attachments. You can then test the texture of, for example, yogurt, right? Or you could have some sort of physiological fluid that you can test. Then we have a rheometer. which is for testing the flow properties of materials. So that goes sort of from -5 degrees to +220. And it'll tell you the rheological properties of the material you put in there. So essentially it works by putting a sample of material between two plates, and then you move those plates in a particular way. And then the stresses and strains, the forces, basically the torque that you're experiencing by moving that, you can start to tell things about the, well, quite exciting, very interesting things about the properties of the material that's in there, right down to be able to infer things about the sort of molecular weight of the material. Melt flow index, very simple instrument, very common in polymer operations. You load it up with polymer, you put a weight on it at a set temperature, and then how quickly it gets pushed out of a hole tells you certain things about the polymer. Then these machines here, now apologies for people online, they don't see me pointing. I don't know how to get a pointer on the screen.
They can see it.
Oh, they can see me. Oh, right. So this is these two machines here are hardness testers. So you put a sample in, you apply a known force with a known shape of indenter. You then look at the geometry of the indentation. Afterwards, it will tell you things about the hardness of the material. That's very important, particularly, let's say, in additive manufacture, so 3D printing. You can tell how hard something is. I don't have my durometer on screen there either. We can test sort of hardness of silicons, things like that. Or if, let's say, you've got a welded component, and that could be plastic welded, or it could be metal welded, and you want to make sure the hardness profile doesn't change across the hot zone. So you would run a profile across, and you can see the hardness of the material. And I mean, where we've used that very effectively recently, someone came to us with some material, and they were saying that so the material was coming from exactly the same grade, but two different suppliers. When it was being used in the manufacturing operations, their teams were saying there's something not right here. One material is easier to use than the other. Go back to the suppliers, they say, well, but they're exactly the same. So then, it's because they've got no data to support it. So then what we were able to do is, with these instruments and then a larger tensile tester we have, produce some data that quite compelling. Say, well, look, it's actually very obvious they're different. So they're able to take that back to their supplier. And then this little instrument in the corner is what's called the gas displacement pycnometer, a very accurate way of measuring volume, essentially. So you measure the volume of a component. It does it by, you put your component in a chamber of known dimensions, known volume. You then flood it with high purity nitrogen gas. It knows how much gas went in. It knows how much gas should go in. You take one away from the other, you know the volume of what's in there. You then take the mass of your item, and then you get the density. And where that's extremely useful is when you start to go with porous materials. So we do quite a bit of testing for 3D printed materials. So let's say you're doing different 3D print densities. You can then sort of map the density to physical strength. Yeah, and because the 3D print is porous, the gas gets into open pores, you get a much better representation of the density of the item. These are two of our larger tensile testers, 60 tons, so 600 kilonewtons, the one on the left, the blue one. I think that's the only one in the country that goes up to that. So if you're in that sort of space, right, so that you're talking pretty chunky testing there, right, then that's available. Some of the work we've done on that is sort of coatings on bearings. So we get a bearing, maybe it's got some coating applied. We apply a very high force onto it, and we oscillate that force slowly. And then you can see if that's had any detrimental effect on the coating of the bearing. You can bend things, wind turbine blades we've had in there. The one on the right here, that's more of a sort of fatigue tester. Does the same thing, it'll push-pull, so do the sort of tensile test, compressive test, but also twists, can do that at the same time, so introduces torsion, can introduce torque. And you know, we've tested a number of things on there. Again, for example, you can take a wind turbine blade, you could take a medical device, an implant, you think of, say, a hip joint, right? Then you can mount the hip joint in there and you can submit it to as many cycles as you want, twisting it, pushing, pulling it, either to failure or for 1 million, 2 million cycles. Just a bit of general workshop space, manual lathe, manual mill. That's an injection mold there that we do some work on. Sort of 3D printed tooling, sensorization of the mold to get some information back on the devices that are in there. This is a CMM, coordinate measuring machine. Basically just takes very accurate and precise measurements of components. Uses 3 methods, so visual, sort of video. You can zoom in your components, you pick points on it, you measure dimensions. Tactile, you can touch and it moves around. And it also has a laser function as well, where you can very, very accurately and precisely pick a point on your item. But you can also do surface profiling. So, we've had people come to us and say, well, this is perfectly smooth, Russell. And then when we do the profiling, you actually see it's not perfectly smooth. And then that's not what they were after. Yeah. And it's got a full sort of CAD system on it. So you'd load your design in. That's your truth. That's what you want. You then produce your part. You put your part on it. You measure your part, and it overlays your measurements onto your CAD drawing. So you can see, is my manufacturing process giving me the tolerances that I need? Yeah. So very, very common in medical device companies, very, very common for implants. Stryker down south would have dozens of these things, just constantly measuring the components that they manufacture. Then we have some new equipment coming in. So this is what's called electrical discharge machining, where you don't remove, it's for metal, where you don't remove the metal by a mechanical mechanism. It's basically, some people would call it spark erosion, where you oscillate a current between a wire electrode and then the workpiece, and that sparks away the material. And you get extremely fine tolerances, extremely fine finish. It's 3, they all work on the same principle, but one is what we call wire, so think of like a wire going through cheese. That's how that does it. One is what we call sink. So think of a hot knife in butter, right? And then the drill. I don't know what the analogy for the drill is, okay, but it's basically, it's the same as the sink, essentially, but for doing very long holes, right? But perfectly parallel, would be very narrow. And you'd use something like a drill to set up your workpiece to thread the wire through for the wire. Yeah, so these machines are used a lot in sort of injection molding for very intricate, very precise mold manufacture that would then be making a device. Yeah. And because everybody and their auntie has an electron microscope, we felt we needed to get an electron microscope. So that's also on its way. And well, yeah, it's got energy dispersive spectrometry on it as well, so we're able to tell what stuff's made up of. Then this is more in the metal space. These are just sample preparation so that we're able to look at sort of grain structure in metals. On our new electron microscope. We also have an optical microscope. There wasn't a picture of it there, quite a nice one. And then this little light at the bottom right corner is basically a desktop high pressure water cutter. So you've got, maybe you want to cut things, acrylic, right, which can be a pain to laser cut, wood, maybe a couple of mil of steel, aluminium, then we can cut it we'll be able to cut it on the water jet. They were like the hard services, right? And I'll come back to some of the soft stuff, right? So we do a lot of design optimization. We do a lot of that. We do a lot of modeling, right? So CFD, stress, that type of thing. We really recommend people do that before they start to cut material or print material. We help people in the prototype designs. We also help on the data analytics side, looking at doing a big project that's now involves a lot of data, building models, looking for anomalies. And then we also will look at people's manufacturing processes. So I spent a long time in manufacturing and R&D. I can usually spot when something could be a little bit better. And I think that's it. That's it. Thank you.
So I was wondering, is there anybody on the floor here that has any questions? I got one question that was texted to me.
Maybe I'm defining an element in that.
Yeah.
Could you use an innovation voucher to get APA done?
Absolutely. Yeah. Totally. We've done that quite a few times. Yeah. Yeah. And what you can also use. So I'm probably going to use the wrong language, right? So if there was somebody from Enterprise Ireland here, they might say, Russell, that's not quite right. Okay, so, and I know they'll probably watch it on YouTube and give me a call, right? But you can set up with your innovation voucher. A lot of people think you have to use it all at once, right? You don't, right? So let's say you get your innovation voucher and you're doing some testing to support a novel bit of work that you're doing, right? You can do a bit of testing, take the data, ingest that into whatever you're doing. Let's say that testing cost €1,000. You've now got €4,000 left on your innovation voucher. You can come back and do maybe a different bit of testing, or you might say, right, well, now actually, I want to maybe build up a little bit, take that data into a model. Yeah, so you don't have to spend the 5,000 all at once on one thing.
Yeah. Is there a time limit?
There's 12-month expiry on a innovation voucher.
That's before you actually put it into use, or when it's in.
There's I think it's both. So you can have an innovation voucher for up to 12 months, right, before you start it. But then once it's started, I think you've got 12 months, but it can be extended. I mean, life happens, so it can be extended. They get extended all the time. Ideally, you get it done in the 12 months, because if we can't spend 5,000 in 12 months, my wife will spend that pretty quick, right? So, but things happen. So that's one thing to keep in mind, yeah, because some people do think, well, I don't have enough to do 5,000. So, well, get the innovation voucher, do what you need to do, and then we take it from there.
Is it for digital developers? Like
yes, you can, because there's gateways that operate exactly in that space. So there's gateways that's what they do. That's their job. So our gateway does that kind of stuff. There's I think it's Design Plus is the name of the gateway, and they're all about AR, VR type development, app development. And so innovation vouchers absolutely can be used for that. Yes is the answer to the first bit. So private individuals can pay. So you could rock up with your own cash, right, and pay for access to that. Yeah.
That means that we have a technician operator.
Yeah. So we have the people that operate the machines. Yeah. Absolutely. Yeah. You can't rock up and go, well, I watched Titans of CNC on YouTube and now I'm ready to go. So no, we've got the staff that run it. Now we don't we do try and encourage people to sort of, if you've got something, to start a company, because then that unlocks all the funding. Yeah. But we have done work. We have done work where people have said, well, I don't want to start a company yet. I'll just pay for it to be done. And then we just set you up as a customer. With ATU, you get invoiced for it, you pay the invoice.
CFD fund that's done work.
They also do it. Yeah.
That's done the Sligo.
Oh yeah. And I imagine they do it here as well. But yeah, no, we do quite a lot of CFD. And in fact, the individual we were talking about earlier, that's his absolute strength. Yeah. But we've done CFD on tidal projects, wind projects. We're actually doing some work on a Formula One project at the moment. So we're not the only ones that do CFD. It's more tying it into, so it's the complement. Yeah. So imagine you're building, right. Okay, I'm gonna. So you're designing a new stent, right, or an implant. Yeah. You've got a design. You now want to see how that impacts blood flow, right? So you can do that, and you can do the design, the machining of something, the printing of something, say with PEM, and you get that whole service. You don't have to take the design, have someone else do the CFD, come back, maybe reprint something or remachine something out of plastic, and then send that off again. Yeah, it can all sort of be done in one spot. Yeah, and the other gateways would say the same. So SEAM would say the same. They would say the same. As the benefit of us being able to do, CFD, for example, is it can tie into your the other aspect of the project that you have with us.
So just two quick questions from people online. One would be just in terms of your slides. Is it okay for us to distribute the slide deck?
Yes.
To the attendees today?
Yes. Yeah.
That'd be great. And the second question is just in terms of design for manufacture. Like you've had experiences where you get companies and they might have a prototype design. Yeah. And they're kind of fixed in terms of this is the way it's going to go. Yeah. And then they go to the manufacturing step and come across a lot of speed bumps. Like what would be your advice to those types of?
So as I would say, start considering design for manufacture or any of the sort of design for methodologies as early as possible. Yeah, because the further you go, the more you get locked in, the more difficult it is to go back and change it. So if you do have a prototype, yeah, even if it's too late to make changes at this stage, talk to someone about what can be changed when you get the chance. Yeah, we do see a lot of people come in with things, and they're so far down the line that they don't have the time now to change the design. What we see quite a bit actually is someone will come and say, "Oh, can I get one of these made because I'm going to a funding competition next week, and I need one to have in my hand to put on the table." And we look at it and go, "Well, okay, yeah, we can make one of those, but it would be much better if that was like that, or you've got, you don't need this here, or that's too thick. Is that the right material that you should?" So it's really just that early engagement. So
there's lots of benefits in from the company having that early engagement with you as well at that early stage.
Definitely.
So you can help them through the process.
Yeah. Now we certainly can. Now, one of the things, so on full transparency, one of the things that we are not, right, is we are not product designers, right? Now we will obviously help design products, don't get me wrong, but we're not a design house, right? So we're not someone you go to and say, right, I've got an idea for a new toothbrush, right? And they go, right, talk to me about your new toothbrush, and they sketch it out, and they give you this amazing picture of a toothbrush, and then you go, that's exactly what I was thinking about, right? But then you take that toothbrush to a manufacturer, and a manufacturer will say, well, yeah, that's some toothbrush that, that's not really going to be that easy to make. If only that was like that, that was like that, you didn't have this, then you could make it at a reasonable cost. We'll make that for you, but you're going to need your own bespoke tooling. You're using materials that nobody else uses, and it's going to cost you an absolute fortune. So so we're not that side, yeah. So I'm painful experience I'm talking about there, right, on the toothbrush bit. But also, when I was in GSK, we launched, I don't know how many products, and the number of times marketing will go and design a product, right? Nothing against marketing, don't get me wrong, but you'd have somebody come to you with a product and say, Russell, this is what the market wants, and they want it for £1. I'll say, fantastic, that's great, and they can have it for £5. I say, no, Russell, you don't understand. The market is only there if we can make it for £1. So, well, to make it for £1, it has to look like this, use these materials, use this process, and you start peeling it back, and they're like, well, I can't, it's not there now, Russell. I say, well, okay, that's why you need to be talking to, you need to get everybody in the room at the beginning. Yeah.
Thanks very much.
Okay, thanks very much. Thanks very much, folks. Thank you.
Sorry, just one more question online. Jamie
Sure.
said he applied to EI 2 months ago to register in order to start the innovation voucher application, but he hasn't heard anything back from them yet. Any advice?
I didn't get the first bit. Somebody's applied online.
Yeah, they have applied to EI, Enterprise Ireland, about 2 months ago to register in order to start the innovation voucher application process, but hasn't heard anything back from them.
Right, so if they've applied directly, okay, my advice would be flood their inbox, right? Maybe better advice though would be link up with your local gateway.
Or
Okay.
talk to the local DA.
Yeah. Now they might not have a DA yet though, if they're very early. So that's your advisor. So if someone has an advisor, an EI advisor, absolutely they're the person to talk to, and they'll light a fire. But if you can link in with a gateway, then there's usually someone in the gateway. So for example, me or I have a colleague, and we would be contacting Enterprise Ireland and just, yeah, because sometimes it can fall in the gaps, and so you just have to keep on at them. Sometimes what we've sometimes what we've seen is resubmit the application, because then they'll come back and say, wait a minute, you've applied twice, and you go, yes, brilliant, but I just want one of them.
Yes. Apply through PEM for an innovation voucher?
You can use us to apply, but you have to apply. Yeah, but what we do, and we do this a lot, is we help, and we'll help pull it together.
Okay.
But the individual or the company, they have to actually make an application, but we will help you pull it together. Yeah.
Very good. Okay.
Thanks very much, folks. Thank you.
Mine of information. I don't think I'll ever look at my toothbrush the same way again.
Or your toothpaste.
Or my toothpaste, yeah. So I just like to thank Russell for taking the time out this morning, and for those that are here in the room, Russell's going to be here. We have a room booked up until 1 o'clock. So if anybody wants to have a one-to-one Russell or a quick chat, you can form an orderly queue is what I would say, and you can talk to him. So thanks very much for those that have joined us online. The recording will be up on YouTube either today or tomorrow. So thanks again for joining us, and have a good day.